relationship between cost and productivity one more time. This time, we're going to look at how average variable cost is related to the average product of labor. Now, stop for just a minute and make sure you're clear on what these concepts are. The average product of labor is the amount of output that your factory produces divided by the total number of workers you're hiring. That is, average product of labor is the output per worker. Average variable cost is your total spending on labor divided by the output that you produce. That is, it is your labor cost per unit of output. Now, how are these two concepts related? I'm going to do a little bit of math, like I did before when I discussed the marginal product and the marginal cost. And I'm going to show you mathematically precisely what I mean by the relationship between average variable cost and average product. Then I'll give an intuitive explanation, and then I'll show you some graphs that summarize this relationship. First, let's look at some math. The average variable cost is equal to what? It's equal to the variable cost, that is the total amount of money that your firm spends on labor, divided by the total amount of output that you produce, the total product of labor. So here is spending on labor, here are the number of televisions you produce. Well, the variable cost, as we've said before, is equal to the wage multiplied by the number of workers you hire, and we can divide that by the total product of labor. Well, if that's the case, then I can divide the numerator and the denominator of this fraction. I can divide both parts of the fraction by the number of workers that we hire, and we get this. W, that is the wage, divided by the total product of labor over the number of workers. Now, what is this term? What is this term right here in the denominator of my fraction? It's the average product of labor, output per worker. So the average variable cost is equal to the wage divided by the average product of labor, AP. What have I just proved? I've just used a few steps of math and logic to prove that the average variable cost, that is the labor cost per television you produce, is equal to the wage divided by the average product, that is the output per worker at your firm. Let's see if I can make this a little bit more intuitively clear with an example. And again, I'll use the example we had before. Let's suppose that one worker can, on average, produce 1/4 of a television set. If one worker can, on average, produce 1/4 of a television set, then it's going to take 4 workers, on average, to produce 1 whole television set. If the average product of labor is 1/4 of a television per worker, then it takes 4 workers to produce a television set. That means you've got to hire 4 workers at $1,000 each to produce a television set, and that's going to be the labor cost per television set, $4,000. If, however, one worker can produce half of a television set, if one worker can produce half of a television set, then it's only going to take 2 workers to produce a whole television set, and that means your average labor cost is only going to be $2,000 per television set. The more workers it takes to produce a television set, the higher your cost. And the lower the labor productivity, that is, the less that a given worker can produce, the more workers you have to hire to produce a whole television set. This is the relationship between productivity and costs. When average product is higher, then it takes fewer workers to produce a television set, and the average labor cost is therefore lower. Let's look now then at the relationship between the average variable cost curve and the average product curve. And here I have it drawn. When the average product of labor is increasing, that is, when it takes fewer workers on average to produce a television set, when one worker can produce more of a television himself or herself, then the average variable cost is falling. As workers become more productive, it takes fewer workers to produce a television, and the labor cost per television is falling. Finally, the average product reaches its maximum. And after that point, if you hire extra workers to produce more television sets, the average product of labor is falling. That is, the typical worker now produces less and less and less and less. That means you've got to hire more and more and more and more workers in order to produce a television set, and the cost per television is going up. The labor cost per television increases as the average product of labor falls. Now, you can look at these two diagrams again and see that they are very, very closely related. When average product is increasing, average variable cost is falling. When average product is at its maximum, the labor cost per unit is at its minimum. When average product begins to fall again, average variable cost begins to rise. The curves are mirror images of each other. This looks a lot like the same kind of picture we saw a few minutes ago when we compared the relationship between the marginal product curve and the marginal cost curve. Now, what we're going to do is put all of this together and look at the relationship between marginal and average product on one hand and marginal and average variable cost on the other hand. Let's focus on the